Okay, so look at the shared screen here. I just wanted to go over first and foremost part 4 of the for and while loop review. This is in preparation for your midterm. We'll also go over part 6 at some point. That may be in person, that may be online, most likely in person, however. Just wanted to dig into part 4, as this is when everything gets a little bit more complicated. Just stemming off of what I have right here. This is a code that I created to emulate this. So just keep this in mind as we're working. Study the code below, determine how the code can be rewritten into both a while and a for loop. Write the code for your loop below. Feel free to test your loops in Python. And I'm just going to double check. So how do we go about that? We have a color mode here, so that's a pretty easy thing to do. Just pop that in, and the fill will automatically be generating from that parameter or variable of color mode. And this requires 3 arguments. So those arguments are ranging from 0 to 100. In this case, we're using fill to fill in a rectangle. What we want to do is generate a rectangle so that it not only has a coordinate kind of descending system. So you'd have the rectangle go about its visualization in this kind of fashion. So rectangle, rectangle. And each time it's moving over and going down a certain amount, right? On the canvas. The main amount that is changed is 50. So it's actually going down by 50 in the x, so x minus 50, and then going down y minus 50. And that's how it's getting those kind of step-like visualizations, meeting its endpoint at 50. So 50 is the size of the rectangle, so that's quite convenient, and that's why it ends up at that corner, right? You're taking the 50 width and 50 height. If you do take that consideration, you could see how that would end up in this fashion, being that the rectangle is indeed going down 50 at a time. And actually it'd be 60. No, it is 50. Excuse me, going up 50. So we're actually starting from 10 and going up 50. Excuse me. And each time we go up 50, we'll just get another stair to that visualization. The fill here represented as going down approximately 20 at a time. Yeah, that is 20 exactly, actually. So it's 100 minus 20, 80, 80 minus 20, 60, 60 minus 20, 40, and so on. And this changes the sort of the hue, right? So hue, saturation, and brightness. We're utilizing a HSB color mode. It's not RGB. So we're not actually changing red. We're changing the hue altogether within this sort of 100 range. And also forming that step via the right position, X and Y. I'd like to just use one variable, one local variable to give me what I need, because X and Y are going up the same amount each time. They start at the same amount each time. That's another thing to consider. So there's really no point in making two variables for this. All we really need to do is make one variable that we can use in both areas and allow it to function as a for loop with that sort of condition, sort of plus equals condition, or I guess in this case, it wouldn't be that. It would, well, the update would be plus equals, but the condition itself would be something like this. Within the for loop, initializing that x core, we could just, technically you could just call that coordinate because, or core, because I mean, you can really call it whatever you want, but I just happen to call it x core, right? So to negate any confusion, just ignore that x when it's in that y position. It really has no correlation. We're just using that as a variable name, and we're using it twice. So in this case, the condition or test condition would be x core less than 210. The update and or draw is x core plus equals 50. And we're giving the for loop, it's three statements here, right? So initialization, test and or condition, update and or draw. Remember, a for loop needs three statements. Then we're going to say to the for loop, hey, I want to, whatever is in this, I want the variable to change for the hue. I want the hue to change, but the variable is needed in order to do that. Or a variable is needed because there are multiple things that need to change later on down the stack of code. Right? So you do need that variable in order to implement that change for the hue HSB. In this case, we'll go ahead and create the local variable above the for loop within the whatever function that it's in. And the color mode, just be sure to assign that, make sure that's defined as, otherwise, these three values are kind of irrelevant, or they become irrelevant to the default color mode of P5. So when you initialize that local variable, you're giving it a sort of starting point as well, because remember, we're descending down from a number, that number being 100. So you want to subtract that by 20 multiple times. In order to do that in succession, we need to create the reds 2. I'm just calling it reds 2. Again, has absolutely nothing to do with RGB. It's just how I remember it, recall it. Feel free to use, perhaps hue 2 or hue 1 or something like that, right? You can utilize whatever name you'd like for that as long as you initialize it, and it doesn't actually obstruct any variables that may be within P5 itself. So in this case, I put down red's 2 here, minus equals 20. And that's going to allow that to change in succession or descension, really. As the rectangle is formed, there's steps down. So we have the x coordinate, the y coordinate, and the size of the rectangle. And we'll go ahead and test this out right now. So here I'll just keep that background color there. It shouldn't be too much of an issue. I am going to make it a nice color. It's purple or something, violet. And I'll make that color mode change. Create the local variable for that fill, for the hue part of the fill. So let, in this case, I'll just make a totally different variable here, just so it's a bit easier to recall. So hue val 2 perhaps. I also want to define it so that we have some sort of starting point. Now, what occurs below that? That's the next question that I'd like you to think about. And yes, you could put color mode below that, or do it as I did, just put color mode above that local variable. So as we've already done both, let's just start with that for loop. It's the for, and visualize some kind of coordinate type thing. So let core 1 or something, short for coordinates. Maybe core 1 less than 210. That's the sort of test condition we want. We want to less than that number. We'll be kind of ending in that number as well, right? Get that parentheses out of there. Cool. 1. And in this case, we're going to remember we're going up by 50. Both counts here, so we don't have to make 2 separate for loops or anything like that. Close the parentheses, get your brackets in there, and enter. Now give it those change statements. So in this case, we'll say fill. We're going to utilize that local variable there, that hue val 2. Hue val 2. We'll just retain the other saturation and brightness. We'll give it a rectangle statement, so rect. In this case, we use core 1. Size, we want it to be 50, so we can make some proper steps here. And now change the hue val to the appropriate change. This in itself is a sort of change statement, right? So hue 2, going to subtract equals as a sort of shortcut operator. Remember your operators, make sure you study those. Minus equals 20. It's going to go down by 20 each draw. And let's just see what happens when I press play. As you can see, the background is not allowing us to see said shapes. And again, that shouldn't actually have a problem. Let's take a peek at what we've done wrong or what we've done right here. So we have the color mode up top above the local variable. Just put it down just for argument's sake, just because you got a little busy there. We're using Q val 2 equals 100 for the fill. We have a rect at core 1 to core 1, realizing core 1 plus equals 50 to create our fill here. We have all of our curly brackets in place. Too concerned there. It seems as though we have everything in the right spot thus far, but we did not initialize it properly. So what should let core 1 equal? Being that it starts from a certain point within the actual worksheet here, that being 10, should indeed start from 10 because we're adding up, we're not subtracting like we're doing with fill, right? Fill starts at 100, rec starts at 10, and we go up by 50 each draw. Let's make that equal 10. And we'll just see if we have a correction, that we do. Now we have successfully drawn the steps, the rectangular steps, going downward in not only space, but also in hue value. Obviously, as usual, if you have any questions, feel free to reach out to me on Discord. I do want to move on to part 5 at this point. And we'll just, I'm going to go ahead and save this. Always save your work, good practice. I'll just say MidTerm demo. And just part 4. Part 4. What I did forget is the while loop. So the alternative to this is the while loop. It's a little bit different. So let me dig into that a little bit. We want the same situation, but with the while loop, things work a little bit differently. There, I'm going to get a little larger for us. So same instance here. I guess I don't really have to do a demo because I'll just be describing what this is, right? Keep in mind we've already given a local variable, so up top and wherever up here, I suppose this could work as well. So you could say let, in this case, reds to 2. With while loop, it's a bit less complicated, but there are advantages and disadvantages to each operation we actually take part in, right? So keep that in mind. Having an alternative way of doing something can be very helpful in regards to how you approach different projects, different ideas. So this is something that's very, very important to remember. There's always a different way to go about achieving a similar result or the same result exactly. In this case, exact result. So here we've initialized things up top. So we initialized the X core here. We initialized the reds 2 here. This being the hue. This being the X and your Y. And then we've done the same thing with fill. We've replaced the local variable in hue for rect. We've gone ahead and placed the coordinate variable in the desired positions, X and Y. And then we just did some change statements here where we just said, okay, now go and do this. So add 50, subtract 20 every update. Really quite simple in the in the grand scheme of things. And to write that out, it would be just like this, but also whatever you rename these however you wish, right? You don't have to do these exactly. These are whatever you need them to be for your own memory, for your own workflow and preference. And again, if there are any questions, feel free to reach out. But with that, go ahead and make a new layer. And I'd like to just go into part 5 at this point. And again, part 6 will be taken care of in another series in class or online. Okay. Oops. Actually, back to that. Part 5, way down here. I'm going to be making this little sky dome. And simply put, we just want to study the sky dome function. So this is a custom function. You've all made these already. Note that there are some P5 variables in here. These will show up as a magenta or alternative color based on whatever your settings are, but they will be different than any other variable because they just belong to the library, right? So what do we have to do for this? One thing that's necessary is obviously we want to write the call statement. So write the function call statement. That's going to be in draw. And it would assist in helping to draw the sky dome of diameter 100 at the current mouse position. So we need to take this into consideration. So it needs to be a diameter 100. It needs to be at the current mouse position. Now what allows us to do that? Mouse Y, mouse X. These are the sort of libraries variables that we can utilize to direct the program to draw with said positions. So digging into that a bit further, just illustrate it for you here. I'll actually open up. I'll just do it right here. Actually, this will be a bit easier for us. So the part 5 function stuff. You need to give it that call statement, right? You can't just have it, and feel free to copy and paste this into P5 ease of use. I'm going to do right now. Already written out. Why should I write it again? Right. Press enter after that draw function. Paste it in there. Note that we have some issues here. So first and foremost, this is not going to work, mainly because we need a 0 in front of these decimals. Remember, sometimes the decimals get confused with something else. So we have to be careful with that whenever we're creating with decimals. So as of right now, it's saying, oh, everything's fine, right? Not exactly. Nothing has happened. It's just like, okay, there's a function here, but I can't do anything with it because it hasn't been called upon. So why don't we call upon? How would we do that? But we would call upon it in such a way that give the desired outcome. So in this case, we want a diameter of 100. As we can see here, diameter is desired to be in this place. So that's it. And we want to go by the current mouse position. We want to follow the mouse. Mouse X, mouse Y. Just get out of full screen. There we go. Now we press play, and we have this cool little sky dome following our mouse. Lovely, lovely, lovely. Very nice. So what the heck is the next question? Or rather, next request, I should say. Write the statements or statements, including function call, that would draw a sky dome with diameter that is the remainder of frame count divided by 300, located at the center of the canvas. Well, as you can recall, defining the center of the canvas can be done simply with width divided by 2, height divided by 2, right? So let's do that. And we'll actually comment that out because otherwise you're going to have some problems. So sky dome. And remember, it wants to do frame count. Remainder 300. And after which it wants us to be located at the center of the canvas. Just like we stated before, width divided by 2 and height divided by 2 will take us there automatically. We don't have to do any math, right? It's inherent within the canvas itself. Let's play, look at this wild sky dome. This is growing until it reaches a certain amount, which is 300. And it goes back. So lots of little interactions there. What's the next request in regards to this? So next up, we have the write statements. Statement, including function call, what would draw a sky dome with a random diameter between 100 and 500 and a random location on the canvas. So as you might recall, random is doesn't always require a low and a high. But if you're trying to customize your low and the high, it does require it. So in this case, normally random is going to go from 0 to 1, right? To use decimal systems, etc., to achieve whatever random value that is between 0 and 1. But if you are not using the default, you want a very specific number, low to high, then you have to give it to it. So sky dome. Parentheses in, we'll review our request again. Write these statements and their statements, including function call that would draw a sky dome with a random diameter between 100 and 500, and a random location for canvas. Going back here, we can say that the diameter. 500 low being 0, 400. Low being 0. Right. You can see that the sky dome is populated in fashion. And its diameter is also ranging from a low of 100 to a high of 500. Stop it there. Anything else that we can do? Sky dome, particular when it comes to the relationship of sky dome and frame count. Is there another statement we can put in there that could perhaps just alter it a wee bit more? Well, one thing you can do is, because one of the requests was to also divide that remainder of 300, let's just see what happens. If we do divide, how is it going to alter what we're given? And it alters it by literally squashing it. We get this strange line that's just ascending and growing from the middle. So don't be afraid to experiment a little bit. In this case, you know, if during the midterm, one thing I'll be going a little bit easier on is if you got both statements correct. So if you get one of the statements and maybe you get a partial solution for one of, you know, a piece of some other statement I was looking for, or you get pretty close, I'll probably just allow you to get full credit. I will not be so friendly on the final, but for the midterm, that's perfectly acceptable. So we'll save our progress there. And do remember that the 0 is important for that decimal system to function properly. So there's one more factor of the part 5 functions I want to get across here. It's this code fragment. It's missing one key statement. Read the header comment describing that functionality, then just write a sort of correction to make that function match the intent. Right off the bat, I can tell you that there just isn't a parameter. But also, there's nothing being printed. Right? So that's another factor we have to consider. Printed or changing. Yeah, obviously things are changing, but it's not visible in any sort of way. So let's fix that. Go back here. We'll go and draw, and we'll give this a little something to call upon. So in this case, it'll be the same as the color, and we will copy and paste that to P5. Remember, you can use P5 as a sort of launching point for things like this. You don't have to be afraid to use P5 during the midterm. It's perfectly acceptable. You kind of have to, right? It's a whole part of the process. Oh, I put in the wrong spot, so let me just dig that out again. So we need to call upon this function to give it a parameter. we do want to give it something that correlates to do and what that functionality, in accordance to the functionality is desired. So in this instance, we have x2 hue jitter. The code or the comment illustrates or elaborates or describes what they want to happen. So in this case, maps an x coordinate, x coord, to a hue value. Also adds a random jitter and the range minus to plus jitter. Turns a jittery hue number constrained to 0 to 360. An example call would be let ball hue equal x2 hue jitter mouse x5. Then they have the parameters here describing what each do. So let's give a call to the x2 hue jitter. Keeping in mind that we actually have to also give it those ranges, right? We can just give it a sort of, I'll just say 110 here. But we do want to give it a little bit of constraint with the randomness. So we'll just give it a low and a high of 360. So we want it to range between those two, right? And based off this, is calculate hue from x based on the range of hue values is 0 to 360. That's what we've done. We've taken the sort of let hue val, allowed it to be 360 times the chord, x chord, divided by width. Well, what is the x chord in this case? I've just given it a number, so 110, and then divided that by width, just like it does in the code. So hue val is going to equal that 360 x chord divided by width. The hue val range is going to need something to equate to, and in this case, it's minus jitter and jitter as the low and high for random. So we've kind of redefined the hue value, right? In this instance, we've given it a starting point. We're also constraining it to 0. Make that a 360. We want to also allow for some kind of printing or something to happen. So I'm just going to do a print. Log. Let's say hue. And we should get a bunch of populated items here. Yep, it is working. So it's finding random values between 0 and 360. And we have been successful in fixing this code. The main thing to be aware of is that to answer the question correctly, or the request only wanted you to find one key statement. One could argue that the call statement is pretty important, right? But there is also nothing being printed. So either one of those would have been fine and acceptable as an answer. But you actually need that call statement to actually have this do anything. So in the end, that calling the function is this draw, function draw. That's the most important. Third and final for part 5 is to create a rectangle. I'll actually just leave this up. I don't think that's going to be too much of an issue. So function, it's a, I want to do some camel case here, so let's make sure we do that. Write a function named to create rectangle, no parameters, draws a rectangle to the screen with a random x coordinate between 20 and 50, a y coordinate 100, a width of 15, and a height of 5. This also returns the x coordinate of the rectangle just drawn. Do that. Give it the curls. I'm going to call upon it. You need to give it some parameters though. Down here, not in the, because it wants it to be a default parameter, so we're not doing anything here. And the actual call. We do have to give it something down in here. So what might we use? We can actually just make a very basic function, not use any parameters at all. Just say let x, so just make it a local variable, random, give it a low and high, in this case it's 20 and 50. Rect x, and we'll give it these coordinates. So y would be, we want the x to be random, remember, between 20 and 50. Give it a size of 15 and 15, just do this as requested. And actually it's 55 and 15 at the end. Return a value for x, so return x and print to the console.log. X coord is, and x. When we print, we're going to actually just comment this little guy out here. Some issues. Whoops. And now we'll be able to clear that console. We'll get something here. Looks like we have a syntax there. So what is that? It's because we put this up too high. There. Obviously, we have a rectangle being drawn at the moment. This is being populated in random location between 20 and 50, just as we've requested. The one thing that is not happening is the console.log. And that is because it's just not updating heavy draw. So what we can do is we could say Control C. So what I did there is I said, okay, make sure you return X first and foremost, and then print it out, right? Because this was on a different line after X, it didn't know, and I used return. It didn't know that it also wanted, it also should return that because it was stopping at returning X. Continue to count on that one. But here we are seeing the numbers and the shape now going in random. And that's your part 5 review. If there are any questions, as usual, reach out to me on Discord or via email. Part 6, I'll be digging into at a later time, as I've stated. Yeah, I hope that was helpful, and as always, enjoy your days.